All right, so we solved a couple examples. You know, we saw one where we had a current source and we had a couple of resistors connected as such. And it was super easy to solve because we knew that this voltage was 0. And then given that we know the current through these two resistors, we can very easily find this node voltage and this node voltage, right? So that was simple enough. And we solved for a circuit. Here, let me move this down a little bit. We also solved for a circuit that had a voltage source and two resistors connected in this configuration here. And this was also very easy to solve because it was super quick for us to just determine the voltage here at this node. And then from there, we know that this ground node, of course, is 0. And then we could very easily determine the currents through these resistors. And then we know everything we need to know about the circuit. But what if I were to connect a voltage source in this circuit? Right? Okay, so we would basically know the voltage here very easily, and we know the voltage here very easily, but to determine the voltage here, what will we be able to do? Well, we know Ohm's law requires for us to be able to know the voltage across the resistors. And in this case, we know the node voltage here, but we don't know it here, so we couldn't find the current through this resistor. We know the node voltage here, but we don't know it here, so we wouldn't be able to find the current through this resistor. So we're kind of stuck. And then moving on to the other type of problem is if I have a current source here and my resistors are connected like such. Again, well, I know my current here. Sorry, let me get this. I know my current here, but now I have two possible paths for current to flow. Some current can flow here, some current can flow here. I don't know how much current flows here, and I don't know how much flows here. And so I can't really determine my voltage, my node voltage here, because I need to know the individual currents across through these resistors in order to determine my voltage drop across each of these resistors. Of course, I know that ground is 0 volts, but that's about all I know. So I'm kind of stuck with trying to solve these two circuits. And so without any further delay, we're going to move on to learning two of the most important types of circuits. Sorry, not types of circuits, but the two important laws for solving circuits. And those are called Kirchhoff's laws or Kirchhoff's laws. And these laws are incredibly important. And they basically govern all circuits at all times. And they're very accurate, always correct. That's why they're called laws and not a theory, right? A law has been proven. So these are the Kirchhoff's laws for circuits. I'm going to start with Kirchhoff's voltage law because that is the first one that we're gonna analyze, and I'll probably make the second Kirchhoff law in a separate video. But basically, what Kirchhoff's voltage law says, let me go ahead and grab my highlighter, is it says that the sum of all the voltage drops in a loop is equal to 0. Okay, in a loop. So what does that mean? Okay, so if I were to draw a circuit, let's just draw something that looks like this. Okay, and I know that this is ground. All right, and I know that I'll just give these resistors some labels here. Okay, so I know that because I have a voltage source here, current's going to flow in the circuit in such a way. And I've also said this before, but I'm going to reiterate it, that current always flows from higher voltage to lower voltage, okay? So at this point in the circuit, right here, my voltage is going to be the highest. That would be my maximum voltage, because from that point, each time I cross a resistor, I'm looking at a current that has to be flowing from plus to minus. Okay, again, R2 plus to minus, R3 plus to minus. And the plus and the minus, along with the direction of the current, indicate which side of the resistor is at a higher potential, okay? So, if I go around this loop, and I call my current here I, and let's just call my voltage here V bat. Okay, that'll be the voltage of my battery. I can write an equation, what's called a loop equation. Some people call it the loop equation. Some people will just say, oh, I'm going to write a KVL expression. It doesn't really matter. What I'm going to do is I'm going to go around the circuit. I'm going to sum all of the voltage drops in the loop. And I'm going to set them equal to 0, right? So in this case, I would say I'm going to start here. I'm going to start right here at ground. And I'm going to analyze what would be my voltage drop across my battery, okay? Well, my voltage drop across my battery is given by the rating of the battery. I'm calling that V bat. And I'm going from minus side to the plus side. So I am going up in voltage when I go across this element, right? When I go from this node to this node, I'm rising in voltage. So I'm going to add that voltage drop to my circuit, okay? Now I come across the first resistor, R1. I'm looking at R1 and I'm going from plus to minus, so I'm dropping in voltage. So I'm going to subtract that voltage drop. Well, what is the voltage drop across a resistor? We know that V is equal to I times R, right? So my voltage drop across that element is going to be I multiplied by R1. Right? Okay, so then we go on to R2. And again, we are going from plus to minus. We're dropping voltage when we go across this resistor. So we're going to subtract this drop. And again, it's going to be I times R2. That's the drop across that resistor. Let me go ahead and move this over and give myself some more space. And we get to the last resistor. And again, current's flowing down. Current's flowing down. I have a voltage drop from plus to minus, which means I am going down in voltage when I go across that element. So I am going to subtract again, and that's going to be I times R3, and I can set this entire thing equal to 0. Okay? So now I wrote my loop equation, and I have an expression for this loop, which I can now use. You can see that I have 3 unknowns here, but let's imagine I have R1, R2, and R3, and I know their values. And I know the value of my battery. Now I can solve for the current in this circuit because the only unknown that I have left is I. Okay? And then once I have I can determine this voltage because I would know that this is 0 volts. I would know my current. I know my resistance. So this is how we're going to start another tool. Basically, what I'm giving you when I go through all of this stuff, in this basic DC circuits series, when we get into the advanced DC circuit series, what I'm giving you is tools that you can use to solve circuits. Not every circuit is the same. Some circuits lend themselves to different tools better. Some of the Kirchhoff's voltage law might be really useful in some circuit that you see. Kirchhoff's current law, which is the next one that we're going to use, might be particularly useful. Sometimes you can just solve by inspection. We're going to learn a lot of different ways to solve a lot of different circuits. And you're just basically going to be given the freedom at the end when we take the final exam to solve the circuits in whatever way that you see fit. Sometimes I will say on a homework, use Kirchhoff's voltage law or KVL to solve this circuit. Use superposition, which we haven't learned yet. Use superposition to solve the circuit. But then sometimes I'm just going to say, solve this circuit by any means that you prefer. And so all of these different ways are just different tools to solve different circuits, and you'll learn to recognize which tools are better for which circuits, specifically by the homework. I set up the homework problems so that they're very tailored toward the specific method that we learned. And by the end, you will be equipped to solve just about any DC circuit by a number of different means, and you can pick which one's your favorite. So this video has gotten a little bit long. In the next video, I'm going to solve a circuit using KVL, and that'll be our little example. I did this one pretty much purely with variables, and that's not super satisfying, so I'm going to go ahead and solve an example where we actually have values and we solve for the current in the circuit. All right.